I hope you're awake, soldier, because this is going to be the most valuable single lesson in 3D mathematics that you'll receive on this course. Dot products are used everywhere. They are so useful, and by far the most common vector operation that you'll use in your coding career. You understand dot products and how they can help you, and you'll become a great 3D coder in next to no time. So, what is a dot product? Let's look at some code, shall we? Nothing to it, huh? Just 3 multiplications and 2 additions, and there you have it. The dot product between 2 vectors. And all you have to do here is simply call f vector dot product, and it's all there for you. Most often, the vectors that you're working with when using dot products are normalized. The reason being that the result you'll get back will then have almost magical status. It's the measure of how parallel the vectors are to one another. Now, that might sound a bit anticlimactic, but believe me, this is tremendously useful. And getting into it, a result of +1 means that both vectors are facing in exactly the same direction. A result of -1 means that both vectors are facing in exactly opposite directions. And in the middle there, a result of 0 means that the vectors are exactly perpendicular to one another. But of course, it can be anywhere between -1 and +1 and not just at these particular values. More precisely, what this magical number represents is the cosine of the angle between these 2 vectors. So if you wanted to know the difference between the 2 vectors in degrees, you would use the following code. Now, isn't that something? Degrees. We all love degrees because they're just so easy to relate to. So now that we've got this incredible tool, how might we go about using it? Well, let's look at a few examples. What about if we want to determine if a point in space is in front of an object that is facing a given direction or not? So is this point either in front or behind? Yep, that's simple. We didn't even need to normalize the vectors going into dot products here because we just need to know if the result is positive. We don't care about the scale of the result here. And we should avoid normalizing vectors where we can, as it does cost CPU to do that, and there's no need to do it here in this example. Now, let's take a moment to note the vector arithmetic there. You see where we subtract of from point in the first parameter to dot product. What this does is create a direction vector from of pointing towards point. And picture that in your mind. It's no longer an absolute coordinate of any form, it's a direction vector with the distance between the two held in its length or size. And we saw exactly this vector subtraction in our discussion of vectors in the last lecture. And this is another more concrete example for you. And you'll do this kind of vector arithmetic often to derive directions from absolute coordinates just like this. How about if we want to know if a vehicle is facing in the right direction for a given section of track? Well, check this out. So here we can quickly determine if our vehicle's direction is within the range of degrees that we specify to the given track direction. And if the result is false, then pop up the old driving in the wrong direction warning onto the player's HUD. But here, it is important that the input vectors are normalized because we do care about the scale of the result as we're comparing it to another number of a set scale. In this case, angle range. Often when talking about directions in general though, it's tacitly understood that we're talking about normalized vectors describing a direction. For direction vectors with distance held in their length or size, I normally name them quite explicitly like this. So the naming of origin to target I hope makes it obvious what it is, not just assumed to be normalized in this case. If we had named it target direction for example, then the naming would imply normalization. There's nothing enforcing this though, of course, and you should just consider it part of your coding standard. A lot of what a coding standard is removing ambiguity. And one of the things you'll learn as you get deeper into the industry is that the code that you write often lives a lot longer than you think it will at the time that you write it. Now, moving on, how about something a bit more mathematical? Shall we see if we can use dot products to determine the intersection point between an array and a plane? Yeah, let's give it a shot. Look at that, just a couple of dot products and a bit of vector arithmetic and away we go. And just for clarity here, array is an infinitely long line extending from a given origin and in a given direction. And a plane is an infinitely wide, infinitely flat plane at a given origin and orientation. An orientation in this case described by a surface normal. But look at how simple this mathematics is, and largely due to the use of dot products. You're going to see this function a lot both throughout this course and indeed your career. We've only very briefly touched on its utility here, but get ready to see many concrete examples as we make our way through these lectures.